At most universities, there is not a course titled Cloud Computing. Most students leave college without an understanding of distributed systems, cloud service providers, and the fundamentals of how a data center works. Kasper Nissen and Martin Jensen are changing that with KubeCloud, a small, tangible cloud computing cluster that runs on Raspberry Pis. Kasper and Martin started KubeCloud as a master's thesis, and it has grown to a textbook-sized treatise on cloud computing. KubeCloud is both software and a curriculum to teach students microservices, container management, and all the real-world problems of a distributed system. If you're interested in sponsoring Software Engineering Daily or you want to advertise on the show, please send me an email at softwareengineeringdaily.com. I'm looking for sponsors for Q3. And if you enjoy this episode, please share it on Facebook or Twitter. The show grows by word of mouth. That's really helpful for us. And if you have any criticism or feedback, please send me an email, tweet at me. I love to hear from listeners. So with that, let's get to this episode of Software Engineering Daily after a word from our sponsor. We're going to be talking about KubeCloud with Kasper and Martin. Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/sedaily. Hired makes finding a new job enjoyable, and Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/sedaily to get advantage of that special offer. And thanks to Hired for being a continued longtime sponsor of Software Engineering Daily. Kasper Nissen and Martin Jensen are the creators of KubeCloud, a small, tangible cloud computing cluster. It's spelled KubeCloud. Kasper and Martin, welcome to Software Engineering Daily.
Thank you.
Thank you.
On Software Engineering Daily, we've had many shows about microservices and how they have changed the way that we architect software. So I don't want to reiterate too much of what we have had on previous shows, but this is relevant to the entire project that you are working on with KubeCloud. And in order to get an idea of your worldview and what you are building with KubeCloud, describe some of the trends and technologies that are driving the changes in back-end development that inspired your project KubeCloud.
All right. So there's been this paradigm shift, you can say, from these monolithic architectures to more service-oriented architectures. And we actually haven't been out working in the real life with these kind of architectures, but we watched a lot of conference videos on YouTube and stuff like that. And
just like me.
Yeah, just like you. And we thought that this was a really, really interesting topic to go deep into. And we haven't been exposed that much to distributed systems and stuff like that. So it was a really interesting topic for us to dig into. And if I should describe the trend a bit, so for the last, I guess, 3 or 4 years or something like that, we have seen this change into microservice oriented architectures. And basically it's, I'm not going to explain what it is. I guess your listeners know exactly what it is, but basically we are going from these intra-process calls to inter-process calls over this non-deterministic network, basically. And there's a lot of we can go really deep into this, but there's a lot of characteristics and stuff like that. But I do not want to go that deep into that. but the idea to KubeCloud basically came from watching these videos, and now it's called KubeCloud, and yeah, basically we saw a demonstration by a guy called Ray Sang. He's a Google developer advocate, and together with another guy called Arjen Basink. I hope I pronounced his name right. But they demonstrated many of these concepts using a Kubernetes Raspberry Pi cluster.
Right, and we will get into the Kubernetes Raspberry Pi cluster in short order. But you mentioned the distributed systems side of things, and you said you guys are not experts in distributed systems. But distributed systems is becoming this thing that, to some degree, everybody needs to understand. So how much does the average developer need to know about distributed systems? And distributed systems can mean so many things. It can mean your machine in the cloud and your smartphone. That's a distributed system. Or you could be talking about the abstract concept of processes in a Paxos protocol, in this highly theoretical environment. What are the areas of distributed systems where developers should be up to date with and should be studying, should be familiar with today?
Well, that's a big question, but what we saw was that the view that many had was that was this kind of the monolithic application, and these errors on the network that can happen, that are important to know about, that people didn't really know how to handle them. So knowing what errors can happen in the layers below was what we thought was very important, and that was also why we have been working with this term called resilience, and the Michael Nygaard patterns of stability, his patterns and anti-patterns, kind of describing what is important here. We haven't been focused on things such as Paxos or Raft algorithms, but that's of course also important to know.
It sounds like you're thinking more in terms of the applied side of distributed systems. So to some degree, you can just abstract Paxos in your brain as this somewhat expensive protocol of gaining a strong degree of consistency among your distributed system. That's all you need to know about what Paxos is.
I don't know if that's all you need to know, but that is all that we have. That's all that we have been focused on in the course that we have taught with this KubeCloud cluster.
Right. Yeah. I mean, I think that's actually a somewhat pragmatic approach. I mean, it's like these days, do I need to know how Dijkstra's algorithm works? No, I just need to know that it is an algorithm that takes a node and a graph and gives me the shortest path from that node to all other nodes in the graph. I don't really care how I do this, what kinds of priority queues and stuff I use. I just need to know what the algorithm does. And frankly, I think that is the level of abstraction that we should be thinking in terms of developers, because our forefathers have prepared these algorithms for us. They've done the hard work of figuring out how they work. We just need to know what they do and perhaps their runtime complexity. And with that notion of abstraction in mind, the modern cloud solutions that we have today, like AWS, for example, they abstract away some of the difficulties of distributed systems. But there are other things that they do not abstract away. Like, they can abstract away a queue, they can abstract away a scheduler, perhaps, or I don't know, some database complexities. But there are things that they cannot abstract away. And I think this gets at the timeless principles that we need to learn as developers. What are the things that distributed systems, like what cannot be abstracted away into a tool? What are the things that, in your intuition, what are the things that are timeless that we really need to understand as developers?
Oh, that's a really good question. I think that, well, to give some more perspective, maybe we have so Kubernetes. We have been working a lot with Kubernetes and this transformation of the data center, basically, from being machine oriented to being more application oriented, and with the introduction of containers and that technology. And I guess the thing that stays is, of course, the applications. But the big change that we have been watching is this shift from being architectured into these monolithic applications to going out on the network to this non-deterministic network where, basically everything can go wrong, and we need to embrace failures and all of these things. And this of course stays when we go into a platform as Kubernetes. But I guess the thing you're asking is that's of course abstractions is really good, but sometimes understanding the premise of these abstractions, not understanding the premise of these abstractions can be a really bad thing, and a lot of things can go wrong if you don't understand, the level below these abstractions.
So we're talking a little bit in the abstract about abstractions. We should talk more concretely about KubeCloud. So tell the listeners what KubeCloud is and what are your high-level goals with KubeCloud.
Okay, so KubeCloud is this small-scale, tangible cloud computing environment that consists of 4 Raspberry Pis each that are and they are placed in a rack with a switch. So it's kind of this cluster that we used to each group during a course to teach them about the very practical side of distributed systems. So they were used for the students to develop their application, and then we made them shoot it down with load testing and stress testing tools to see what happened with them, and also the features in Kubernetes. For instance, when you pull the network plug, how can Kubernetes then mitigate these errors if you build your application in specific ways? So that was kind of what KubeCloud, what it consists of, and what it has been used for, very briefly.
So KubeCloud is your goal with it is to build a tool to help students learn to work with and reason about distributed systems. As far as I understand, this is not necessarily built to be like a production grade tool that we're using to like deploy like industry applications. It's more of a learning tool. So you can tell me if that's correct, and you can tell me what are the earlier education tools that have been built with the purpose of distributed systems education in mind.
Yeah, you are absolutely right about your description there. It is not a production grade cluster or anything. It's designed to be a learning object, basically. And the tools that comes before, and that, I guess this is actually the problem, because we haven't been introduced to distributed systems in that big of a deal in our education. I just recently listened to one of the shows from, I guess it was SE Radio. I guess you were the host, with Ben Hindman, also from Mesosphere, also talking about this, that there's a lot of the people building distributed systems haven't had that much education within this area, and I guess that's the big problem. And this is what we're trying to do something about, and we really think that this tangible physical hands-on tool is a really good way to actually teach about distributed systems, and especially the things that can go wrong in distributed systems.
Yeah, I agree with that. And I really like your description of the idea of a learning object. And then in this master's thesis that you're writing around KubeCloud, you have this KubeCloud project that is it's kind of the center of your master's thesis, but your thesis is also about education and just the process of how somebody learns. It's got this real meta appeal to it. And one of the things that you discuss is this need for a learning object in order to effectively learn. And this really appealed to me as somebody who studied a lot of different things before happening on computer science. And computer science was something that really appealed to me because I was able to program and feel active and interface with the thing that I am learning about as I am learning. It's almost like a dissection as a biology student. Give the listeners a description of this idea of the learning object. What is a learning object, and how does that apply to KubeCloud?
Okay, so yeah, you're absolutely right. We have been actually so we are master thesis students within computer engineering, but we really thought that it was really important to understand what is a learning activity, and especially how can we use a learning object in this sense. So we wrote a chapter in our master thesis about all of these different teaching styles and how you can use this active approach to teaching, basically. There's been a lot of research within topics like problem-based learning, where you use a specific problem in your course to design this course around this problem. And we also took some of these thoughts and used them in our course. And these kind of methods, these active methods, also to some extent open up for the possibility of using this learning object, basically. And a theory like activity theory discussed these things about this mediating tool to actually for students to construct learning by using this object. So this was some of the theories that we were reading about and interested in trying to apply in the course that we needed to design, and the learning object that we then designed as KubeCloud.
Okay, so let's get more of an idea of what KubeCloud actually is. So with KubeCloud, you are trying to build a tangible computing cluster, tangible cloud computing cluster. Describe the technical architecture of KubeCloud from a high level.
Oh, so you mean how it's assembled, or what it consists of?
Yeah. Yes. Just like a high level, like give me as much of the stack as you want to talk about it first, and then we can drill down into it.
Okay, so we have these 4 Raspberry Pis stacked, and then on the operating system layer we run Arch Linux, and then on top of that we have Kubernetes running with one of them as being the master, and we have used the project called Kubernetes on ARM, which is made by a guy from Finland called Lucas, and he this kind of this has been used to install the Kubernetes on each Raspberry Pi, and then it also uses Docker to set up this notion of a Kubernetes cluster for each of these KubeClouds, and then we run different applications on it.
So, for listeners who might be unfamiliar with this space, basically we've done all these shows about Kubernetes, which is kind of like this data center operating system. So you have a data center, and Kubernetes is the tool that you use to orchestrate all the resources among your different servers in the data center. You break them into these smaller components, and where you can do resource management. And what you have done with KubeCloud is you've built this way of basically doing that or you've assembled a way of doing it on Raspberry Pis, and it simulates the entire data center in a sense. It's sort of like the minimum viable product of a data center, and you can simulate the outages on a hardware or a software level all through the stack and give people a tangible sense of interfacing with a data center, interfacing with a cloud computing cluster. And it's funny because tangible cloud is almost like this oxymoronic statement, because like cloud is supposed to be this ephemeral thing. Oh, I just summon a resource from AWS. I don't have to care about how, where in the data center it sits. It's just, but here you're turning that on its head and saying, okay, no, we actually want to have a tangible sense for what this thing is and how it works from top to bottom. And in order to further that notion, let's take a journey from the bottom of the stack to the top of the stack, and let's just start with the hardware. And I'm a little intimidated by this because I am not a hardware expert. I'm a software person. But, the hardware you're using, I don't know what else we could talk in terms of like the hardware stack being a server, a router, and a switch, or maybe you want to go deeper than that. Why don't you just talk about the hardware that you're using at first so we can get an idea of how we should be thinking about a data center, at least from KubeCloud's point of view?
Okay, so as Martin just explained, we have 4 Raspberry Pi model. I think the Raspberry Pi 2 is Model B. So this is this low cost, nice little device that actually have some all right power, I guess. It's I think it's 900 megahertz processor, quad core, and has 1 gigabyte of memory, as far as I remember. And it's actually a quite nice little device. So that's the hardware part. Then we have, of course, a switch. So these Raspberry Pis is set up in the star topology with the switch in the center. And we actually have, so that is 1 KubeCloud, and we have 8 of these small KubeCloud clusters that can then be assembled into 1 big cluster if you would like that. So that's the hardware side of it. I don't think there's that much more hardware than this, and we are not hardware experts either. So
certainly. So the components of this hardware stack that I did want to touch on that are components of a data center that software engineers might not be super familiar with are a server, a router, and a switch. And we've heard these topics as software engineers, but they're things that maybe we haven't delved into. Can you explain the responsibilities of a server, a router, and a switch?
Well, so in our setup, we have used the server as this unit of resource that we then can combine, or that we can assemble multiple servers of, and then they are connected through this switch in our setup, and then again further to a router, where the router then has the responsibility of assigning IPs to our servers.
Okay. So what about the what is a router responsible for, and what is a switch responsible for in a distributed system in a data center?
Oh, that's a really good question. So the router is basically responsible for, again, we are using it in our terms. So we use the router as this gateway for basically the internet connection. So for us to be able to use Kubernetes on these devices, we need access to the internet. So we use the router as this piece of device that we can connect to, and then then every KubeCloud basically gets access to the internet, and they can download the images that they need from Docker Hub, for example. So the router basically acts as this proxy to the internet in our case, and the switch is it's basically just connecting the different Raspberry Pis together so that creating the network between the different devices. So that's basically how we use it.
So as you're building this KubeCloud and you're constructing you're wiring these Raspberry Pis together. I mean, the root of these questions is basically, as a software engineer, like I've been using Macs for most of my career. So I have not built my own computer. I'm somewhat ashamed to say, but I actually think that many of the listeners are in the same boat. They've never built their own computer and they have no sense of the hardware that they're using. And I think that's fine, but it's also fine to say, let's build our own data center on Raspberry Pis. And so, your explanation of routers and switches, is that all that you need to know as a couple of engineers who are building a data center out of Raspberry Pis? Is that literally the extent to which you need to understand routing and switching?
Well, in our case, it is. We haven't been digging deep into each of these devices' specific responsibility. But these are everyday devices that you just basically use in your home network and stuff like that. So we just needed some commodity hardware that were easily be connected to each other. So that's how we use it. We haven't been going deep into what is specifically the router's responsibility in a data center, but we use it in our way in KubeCloud basically.
The thing that we used it for were the thing that we found interesting was this: what happens when you distribute your applications over multiple servers? What happens if one of your servers then disappears? And that was something that we were able to do by creating this, you could say, local network. And then we could do this tangible thing of pulling the plug and then observe what happens. So that was the point for us in having the network physically in front of us.
Okay, so you basically understood the minimum about the hardware that you needed to simulate the hardware failures, perhaps. I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month, so my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. So your Raspberry Pi data center is running several different layers of software that we need to know about. And at the lowest level, you chose not to go with a hypervisor. Maybe we want to get into the hypervisor discussion, but that maybe is not relevant to this. There are other episodes where we've talked about hypervisors, but you eventually ended up with Arch Linux as kind of the lowest level of the software layer. This is just the operating system level. How did you end up with this configuration for the OS level? What were the different operating system discussions you were having about what operating system you were going to run on these Raspberry Pis?
Right. First, we tried out the Hybrid OS. That is these guys who have been doing a lot of awesome stuff on Docker on Raspberry Pi. So what we needed to be able to do to run these containers, well, this hypervisor or container discussion, I might just dig into that just a little bit. And kind of because we went with containers, since hypervisors probably would be a bit overkill for these small devices. Then we wanted a stack that could run Docker and Kubernetes. And to run Kubernetes, we actually saw the configuration that Arjen and Raysang had been using, and that was an operating system called Hybrid OS, and that actually went fine for I think a couple of weeks for us, and then we had some stability issues, and later Arjen also experienced some of these issues. He had been using an older version of Hybrid OS than we had, and the error didn't occur there. So we actually ended up with Arch Linux because of stability issues in the other version that we had been using. And since we had to deliver these small clusters to the groups of students, then we had to have a stable setup. So we actually ended up testing out which version that was most stable in our case. So that was kind of the reason for choosing Arch Linux instead of Hybrid OS.
And on top of Arch Linux, you run Kubernetes, which is managing Docker containers. Describe the process of deploying Kubernetes to the Raspberry Pi cluster. I mean, I'm an armchair architect. I've just been talking to people about how Kubernetes works. What is this? What happens in the event of a failure? What are the different things I can do with Kubernetes? But I have never deployed it, and I haven't really talked to anybody about the difficulties of deploying it. It sounds like kind of a complex installation process, or maybe it's not. Tell me about how you actually deploy Kubernetes to a cluster.
Yeah. Okay. So we were kind of lucky that this Kubernetes on ARM project existed, because there already exists this project from which you can install Kubernetes on ARM, and it's called Kubernetes on ARM. So you actually you can download a Debian package, or you can install a kind of right away from a GitHub a repo the needed files right onto your SD card, and then you actually only have to type kube install, and then it will install it for you. So there is this guy called Lucas who has I think he has cross-compiled to ARM himself, and then shift to some official binaries in the latest version of it, as far as I remember.
Okay, so once you deploy it, you can build applications. So at the application layer, you use Spring Cloud to deploy services. Explain what Spring Cloud is, how you use it, and what the interaction is at that application layer between the services you're deploying with Spring Cloud and Kubernetes.
Yes, of course. Great question. So we needed some kind of framework or something that would get the students easily up and running with building microservices and understanding some of these concepts that we have been teaching. So basically Spring Boot and Spring Cloud basically provides this for us in an easily way by simply annotating stuff. So, for example, we have been discussing the pattern described by Michael Nygaard called the circuit breaker pattern, which I guess is used many places. And basically, you can easily get a circuit breaker pattern in Spring Cloud by basically just writing a few lines of code, and then you're up and running with a really great circuit breaker pattern with a dashboard and everything. So this is one of the reasons that why we chose Spring Cloud and Spring Boot. And further, the students are actually being introduced or to C and C++ and C# before. So the transition into Java hasn't been a problem. So we wanted something that were kind of similar to C# to some extent, and Java was an obvious choice in that sense.
So can you talk more about how you write a service in Spring Cloud, or do you have any examples of a project you would give to your students where you would say, hey, we're going to build these services and this is how you deploy them to Spring Cloud and this is how they interact with Kubernetes?
Yes, so we have used the Spring Initializer, which is, if you go to start.spring.io, you can basically choose the dependencies that you need in your project. So we had a few minimum requirements for what the students needed to add into these projects. So first of all, they needed to use this configuration Spring Cloud Config, which is a centralized configuration tool, basically, where you set up a config server that fetches some configuration from a GitHub repository and then provides that to the config clients. So that was one of the requirements that we wanted in these projects that the students had to build. Another requirement were the use of the API gateway pattern, which is also really easy to use in Spring Cloud, because Spring Cloud is combined with a lot of these Netflix open source projects like Zool, which is this gatekeeper that actually provides you with this API gateway pattern. So this was some of the requirements that we had for the students to these projects, and they can basically just go to start.spring.io, choose the dependencies that they need, download or generate a project, and then they can start building from there. So they get everything set up and they are ready to basically write the code that they want in their applications. So that's a really, really easy way to get started with these services that were needed in these projects.
So we're talking about teaching students with KubeCloud, and listeners might be confused. This is like a project about attaching Raspberry Pis to Kubernetes, and it's also a master's thesis. And is it also a course, or what exactly is going on here? Are you teaching people with KubeCloud? Have you actually deployed this to classrooms and used it in practice?
Yeah, so to explain it in more detail. So we got the opportunity to, so it actually started out by us wanted to build something with Raspberry Pis and Kubernetes, because we thought this was really cool. And then it turned out that there were some problems with students not being introduced to these distributed systems, or we thought we could do something here, and we got the opportunity to design this course about microservices and Docker and Kubernetes and resilience and all of these things, and we actually taught this course for the past a couple of months now, I guess, and we had the exam in the beginning of this month. So we have been. So this was part of our master thesis as well, designing a course and actually building KubeCloud to provide the students with this learning object for actually getting some hands-on experience with these tools and trying to build these microservices and actually testing them as well with the different testing tools that we have also provided them. So it's a lot of things. It's the course and it's the learning object, and this is what were the topic of our master thesis, basically.
The learning experience of the education curriculum, which you recommend from KubeCloud, has several modules. Give me a rundown of those modules. What are the modules that you urge people to learn through KubeCloud?
Yeah, so the first module is about that's an introduction to this new way of architecting your application. So that's kind of the transition from the monolith to microservices, and then with that knowledge, we built module two around containerization and hypervisors, most focused on the containers and especially Docker. And then knowing about how these containers work, we introduced Kubernetes in module 3 to orchestrate all of these containers that you build to get some kind of way to manage the complexity of having a lot of containers. And then module 4 is about that's about resilience and what can go wrong now that we have a lot of independently deployable applications that communicate over a network. Then we have, then we need to be able to handle if something fails. Since we don't have this one unit, we have these multiple units that independently can fail. Then how does one application handle that another one fails? So that was what the fourth week was about. And then in the fifth module, we had an external presentation from a guy called Martin at Pragma about how they that's this continuous delivery consultancy company, and he kind of presented how they use Docker and how they build these continuous deployment pipelines, kind of to give some kind of link to the real world. And then in module 6, DNS was introduced, not by us, but by another master's thesis student who had been digging into this subject. And then in the seventh week, we talked about service discovery. So how you can do that as a server-side service discovery and client-side service discovery, and how it is done in Kubernetes. And furthermore, the students had to present their own group project in which they had this case of building a resilient e-commerce platform for Black Friday. So the sudden increase in traffic should be possible to be handled.
I love the tangibility of all of these different things that you're covering in these modules. And it is in such stark contrast to the types of distributed systems education that I encountered in college. Not to cast that to the side or throw it in the trash or whatever, but I know that this type of approach would have appealed to me more because it's so much more hands-on. It's very much like these are operational things you are learning. But I can imagine that this might contrast or rub people the wrong way if they're in academia and they're very used to a theoretical approach. What has been the response when you kind of show this curriculum style to academics?
That's a really good question. So we are engineering students, and I guess that makes it more practical in compared to computer science, at least here in our city. So our education has actually been quite hands-on with a lot of different technologies and tools. But of course, we also have a lot of theory about different topics and stuff like that. And we also used 1 or 2 hours every module trying to go through the theories to some extent, not digging really deep, but to actually just give the knowledge that the students needed in order to get going. And actually, this is part of the teaching strategy that we chose, that students need to construct their own learning to some extent, and they need to figure out what they need to solve the problem. So we have a lot of we have tried to create a course that allows students to use problem solving techniques and to basically figure out themselves what they need. But with us as in this facilitating role, being there to help them if they are in need of anything. So that was kind of the idea behind the course. We haven't actually been out trying to get some feedback from the hardcore computer science academia. So, but maybe we get some feedback after this.
Okay, well, yeah, we'll be looking for that. I mean, I do want to talk. I do want to talk some about the academic versus industry research. So, obviously, this whole project is kind of a statement on that the fact that the evolution of cloud computing needs more focus in the academic community. Academia should focus more on cloud computing. Why hasn't that happened?
Oh, that's. I think it's partly because of this rapid moving industry. Basically, a lot of companies are moving very, very fast at the moment, and have been for the past many years since cloud computing were introduced. So there's always been this industry-driven research. So it has been Google and all these big companies doing their own research in order to figure out what they need in order to meet the demand that the customer is basically expecting. And these expectations is, of course, always evolving. So the customers get higher and higher in expectations, and this basically drives the demand on these on us as developers to make better and better solutions and more complex solutions, and in order to meet these demands. So I think the big problem has been this rapid change, and of course that there are a lot of universities out there that is focusing on cloud computing, but there is also a lot that haven't had this focus. So I think that's the main reason, is that it's the industry that has had the need and have
Right. So when industry researchers have made breakthroughs in distributed computing, some examples that come to mind are Spanner, Bigtable, MapReduce. These things that have come out of Google, for example. I'm sure there's plenty of examples from Microsoft Research as well, Facebook Research. These are groundbreaking discoveries of things that we can do in computing. With such a high caliber of research coming out of the industry, why do researchers still spend time in academia?
Well, I think there's also another reason for researchers in academia that hasn't been able to actually do research, because they haven't had the right tools. They haven't had this big data center, these many resources to actually buy and build maybe a data center in their basement, and it's quite expensive to build some kind of scale model that is some kind of replica of or small scale replica of a data center that is actually able to provide you with the resources that you need to do this research. But this is something that we try to accommodate in some way with KubeCloud, because it's actually quite cheap to build these small scale data centers. Of course, they are not they are really small scale of big data centers, but you can actually use them for teaching these concepts to some extent, and you can also do some research on them. We have been trying out these different patterns of Michael Nygaard with the circuit breaker pattern, and try to actually verify some of the effects of using these patterns. So you can do there's a lot of things you can do with a small data center like KubeCloud. But of course, that's I guess the price and and the resources, access to real resources, has been the biggest problem.
What are some examples of the type of research that would be funded in academic computer science that would not be funded in industrial computer science?
Oh, that's a really good question. I don't think I have an answer for that.
So, all right, that's totally fair. And this is what concerns me about academia is that I can't think of something. I mean, like historically, the argument was that there are these like moonshots or these things that are just of pure scientific value that would have no relevance to an industrial company. But these days, I am having a really hard time thinking of projects that fit that bill. The one exception I can think of is maybe the what is it? What is the thing in Europe? It's the like shoots atom smasher thing.
CERN.
CERN, right? Yeah, like that. Right, like that thing seemingly has no direct practical commercial application, and yet we are putting billions into it. And you know, this does in my gut when I look at this, I'm like, this does seem like an important project, but it's essentially, I mean, it's not. I don't know if it's exactly academic, but it's more of a public works project that it's not academic, but it's probably closer to academia than industry.
Yeah.
I mean, are there questions like this in computer science that are so far outside the realm of commercialization that they have to be researched in academia?
That's a really good question. Basically the idea that we had were basically that we wanted to provide students with a nice tool for learning these skills. So that was the reason why we got into this.
Well, so let's talk more about that. I should level the conversation a little bit more closer to KubeCloud. So I think this is an awesome idea. I think it's a huge idea. Also, I think KubeCloud is such a compelling idea as a learning tool. It almost to me sounds like it could be turned into an entire boot camp, like an entire coding boot camp you could have around distributed systems. Do you think could you potentially do that? Like, is that a commercially viable opportunity that sounds appealing to you?
Yeah, sure it is. We have actually thought about it ourselves. So maybe there is somebody out there who wants to make this into a product that can actually be sold to universities. But we are doing this. We are trying to open source everything that we have basically found out about KubeCloud, and we would like to provide this as a guide to how you can, as a university, go and buy these Raspberry Pi clusters, and it's fairly cheap. We have spent like $2,000 on these this hardware and of course a lot of time, but you can get a lot for a very few dollars basically.
To what degree do you think you need an instructor for this project? Like, if I'm just some random developer, I'm learning on my own, maybe I'm using free code camp or I'm using Udacity or I'm learning on my own somehow, I hear about KubeCloud and I'm like, well, this sounds like a great way to learn about distributed systems. Should I just like read KubeCloud and go build my Raspberry Pi data center and become a distributed systems engineer all on my own? Or do I need an instructor? Do I need somebody helping me out?
Oh, that's a big question. Well, I think a little guidance is a great thing to speed up the process. But I think that if you have some knowledge already, then you could spend you could spend more time and then learn a lot of it by yourself. There are a lot of great videos on a lot of the topics that really can assist you.
Absolutely, and I will say those types of videos are the backbone of Software Engineering Daily. Much of what I am able to do with this show is thanks to YouTube videos that I watch about distributed systems or talks about whatever. It's an amazing resource. So I want to talk a little bit more about the project. KubeCloud is this really long master's thesis, I'm sure most master's theses are quite long, but it has so much information. And one of the pieces of information that you have in the project is these collections of surveys that you did, kind of these Quizlets. Describe what these surveys are and what you discovered in them.
Okay, so we wanted to find out if KubeCloud was a good idea or not. So we actually we did we both did weekly kind of reflection assignments that the student had to hand in, and within these we asked questions about KubeCloud and the effect of how did KubeCloud help you in this week's topics and stuff like that. And then at the end of the course, we also asked them about the overall rating of KubeCloud and the learning activity that we have designed around KubeCloud. And if we should talk a bit about the results of this evaluation, it basically showed that KubeCloud was a really great idea, especially within the area of providing a better understanding of errors in distributed systems. So we asked a question about that, and 87.6% of the students either agree or strongly agree with that statement that KubeCloud provides a great understanding of errors in distributed systems. So this was one of the great findings, and this was also what we expected, because in the week that we were discussing resilience, and we actually had an exercise that the students had to do as well, and the exercise was for 3 minutes to put a lot of load on the cluster, go up to the cluster and pull the plug and watch the effect of having replicas, so having multiple pods running the same application. And they were, after that, they were really keen on just shooting down the cluster with a lot of attacks, and it was really great to see, and they really also tested their own application with these different tools that we provided them. So the overall evaluation was really great, and so we asked a lot of different questions into different categories, and one of the other important ones were visualization. So there's this visualization tool out there for Kubernetes, and it provides a really good insight into what's going on inside a Kubernetes cluster with the great visualization of if you pull the plug, the node is turning red, and you can see the rescheduling of pods happening. So this was also a really so KubeCloud combined with this visualization tool were really a good combination.
So what's in the future for this project, and what's in the future for you two? What are you going to do after your master's? What is left with the KubeCloud project that you still need to accomplish?
So we would like to open source whatever we have found out. So we have a GitHub repository out there, and we have a blog as well. And we will for the next couple of weeks we will be putting out some articles and blog posts about different topics within design. We already have a blog post out there about how to get up and running with Kubernetes on ARM, and there's pictures of our clusters and stuff like that. So that's that already, and we have a GitHub repository where we have some of our applications already. But we'll be putting our idea is to make this kind of assembly kit in some way where you can, basically as I talked about earlier, as a university you can take this and you can get up and running pretty fast with this kind of learning object, and of course our experiences running this course as well.
That's great. Well, Martin and Kasper, thanks for coming on the show. This has been a great conversation. I'm glad that you guys are building a meaningful learning object for distributed systems with KubeCloud.
Thank you for having us.
Thank you.